Hey guys, I'm not going to do every single problem in detail, but we'll get you all the answers and we'll do a lot of the setup for you and the story problems as well. So here's IC number 82. Number one, you see that we have a right triangle, and the first thing you need to do is you need to go find the legs, and the legs are always going to be attached to that right angle. In this case, they gave us 4.5 for A. The hypotenuse is that unhighlighted side of the triangle, so we'll put that in for C. And in this case, we'll just go solve for B. And here's the work for that. Remember how to get the exponent off of the B is because it's to the second power. We can literally just take that off and put a square root sign on the other side of the equation. Works every time. And then, on your calculator, it's going to show 4.5508. But for this particular worksheet, they want the nearest tenth, so we just need to round it to 4.6, and there's your answer for D. Number two is the exact same setup. They'll give you one leg and the hypotenuse. So just make sure you put them into the proper spots. You should solve and get A. 3 is a little bit different. They give us two different legs, 6.5 and 9.1 are the legs. So we go and we put them into the Pythagorean theorem equation. We square both of them and add them up. We get 125.06. Put a square root sign on the other side, round to the nearest tenth. In this case, it should become 11.2, so C. Number 4, the answer is D. Again, they gave it a leg and a hypotenuse. That was kind of like number 1 was on that setup. Here's 5 and 6. Number 7, they didn't give us a triangle, but they went ahead and they told us what A, or at least what B and C was, and said go solve for A. So we put in Pythagorean theorem, and we plug in the information that we know, square what we need to, subtract 73.96 on both sides, and we get to 87.33. Put a square root sign over it, and once you check that into your calculator, what's the square root of 87.33? It does round to 9.3. So B is the answer for number 7. Now we get into the first bit of story problems. If you notice, I went ahead and had a diagram drawn here. It's a rectangle. It's a 10 by 15, and they're saying, hey, cutting it diagonal, what's that going to be? Hopefully, at this point, you can see that there would be a really nice right triangle made right here that I'm kind of sketching in. It would be a right triangle. This would be 10 on this side. So literally, we've got 15 and 10 squared. So we plug them into Pythagorean theorem and we find out that we'd get 325 equals c squared. And once we find the square root of 325, we know the answer. So we got 18.02 or 18, that sort of thing right there. If you rounded to the nearest tenth, it just would have made it 18. Okay. Next problem, number 9, diagonal of this rectangle is a 15 by 25. So really it's almost the exact same thing, but the difference is this time they gave us the hypotenuse and one leg. So the setup looks like this. So it would be 20 inches. Same setup here. They give us both legs this time. So it'd be about 150 meters. Here, I mean, you can see that the right angle of the square would be right here or any corner of the square, but the distance between first base and third base would just be cutting straight across. So really, we just could use this triangle right here to find the hypotenuse, because here's the right angle. That makes the 90s the leg. So here's the setup. So it would be about 127 feet, give or take, however you rounded. On number 12, this one's a little bit better. They said the square is 81 square centimeters. So, if we said what's inside of this square, how can we get it? It'd be base times height or length times width. And that would mean 9 times 9 would get us to 81. So you had to kind of work backwards to figure out the lengths of this. So this is a square with 9 on each side. Of course, we've got the right angle, and we just need to find the diagonal length there. So the 9's are the legs and the x is the hypotenuse. So 12.7, 12.72 again, depending how you rounded. 13, look, it's just a monitor. We're given the diagonal. This is 10 inches by what? So it'd be 10x, excuse me, 10 squared plus b squared or x squared. This is what we need to find. It's a leg. And then the diagonal is the hypotenuse. So the c would become 19, and we need to square that also. So um, once we square the 19, that'd be 361. And hopefully you can just kind of follow subtracting 100 from both sides to get 261. And then, hey, what's the square root of 261? If you don't want to round, this is the actual answer, 261, the square root of 261. But um, to get you a little bit more of a real world feel of how large this monitor is, it'd be about 16.2 inches if you rounded. 14, exact same thing, just, different dimensions here. So let me just pause. And after you work it all out, basically this would be 15 inches from here to here. Very last one, isosceles triangle. This is not a right triangle, but we do have two right triangles hidden inside. And because it's an isosceles triangle, that means that this angle is identical to this angle. And since it's at 90 degrees, we can bisect it. That basically means from here to here is 5 centimeters, and from here to here is also 5 centimeters. So now we just have to use one of these right triangles. Let's just use this left one. 10 and 20 are legs. I'm sorry, 10 is a leg and 20 is an hypotenuse. So let me go set that up. So here we go. We plugged in the 10 and the 20 in their correct spot, a leg spot, a hypotenuse. Now we just got to go work our way through this one. Since this is the last problem for the assignment, I'll just go ahead and let it run while we solve this. And let's see here, the square root of 300. We've got 17.32. So, I'd say 17.3 would be the height of this isosceles triangle.